A cargo ship is sailing above a speeding train right now, both in Victoria Harbour, simultaneously. She reads her phone. Above her, a cargo ship. Below her, the harbour floor. She doesn't know. That crane operator has no idea there is a train tunnel 3 meters under his foundations. Strip the harbour floor back. There they are, 11 concrete boxes, 23,000 tons each, trains inside. 1 drop of water, 30 meters of concrete below it, then a train full of people. The harbour is 400 meters from that sign. East Rail stuck here for 43 years. 500,000 people every morning. They hit the harbour and stop. The east of Hong Kong, disconnected. Every pipe and tunnel below Hong Kong belongs to someone else. The new railway goes in anyway. Now you might be thinking, why not build east? Because the harbour is 1.4 kilometers wide. 5 tunnels already under that harbour. The 6th must thread between them. 90 meters of space. That's the geological layer cake the tunnel must pass through. Every layer behaves differently under a drill. Build sections on land, float them, sink them one by one, under active shipping, at night. A red flag in a quarry starts a harbour tunnel. That is the entire paradox. That red line threads through 5 tunnels, 30 meters of harbour, and 10 years of someone's life. How do you build a harbour tunnel on land? In a quarry, then float it out. 1 wall between the sea and 11 tunnel sections. When casting is done, that wall comes down. 23,000 tons of steel per section. The rebar cage is so dense workers climb through it. The casting bed is 340 millimeters out of level. Cast now and the tunnel never aligns. Grout fills the low spots. 5 millimeters flat across 160 meters. Confirmed. Then the concrete can go in. 36 hours non-stop. C45 concrete. Thermal sensors inside the walls. 1 cold joint and the element fails.
Touch this anchor plate. 30 meters of harbour is coming. These tendons hold the roof.
1 tiny gap in this waterproofing and the harbour fills the tunnel in minutes. Every millimeter inspected. The seawall comes down. The harbour floods in. 23,000 tons of concrete rises. It floats. 30 months of casting. 11 concrete boxes. The quarry is empty. Time to enter the harbour. GPS towers on the roof so engineers can track 23,000 tons to the centimetre. At night. 23,000 tons floating on open water. 5 tugs ready. Victoria Harbour ahead. They go in at night. The harbour lane is 200 metres wide. The tunnel element is 18. This is the tightest part. 23,000 tons moving through a live shipping lane. At night. The ship on the left doesn't know. They are cutting a trench through 30 meters of harbour silt. Then the tunnels go in.
100 millimeter tolerance on the trench base. Get that wrong and the 23,000 ton element tilts. Permanently.
The gravel bed is screeded flat underwater by laser. 20 millimeters tolerance for 23,000 tons above it. Marine police close 200 meters of the world's busiest shipping lane. 48 hours per element. The immersion pontoons grip the element. Ballast tanks fill slowly. The descent begins. 30 meters down. The rubber Gina seal compresses between 2 23,000-ton boxes. That compression is the watertight seal. A cargo ship anchor dragged across the gravel bed. 180 millimeters disturbed. Element 4 cannot go down. Abort. Hold it at 15 meters. Rescreed the bed below it. Reconfirm 20 millimeters. Descent resumes. It lands. Pump out the joint space. The harbour pushes the elements together with millions of tons of force. A second seal goes in from the dry side. 2 seals between the passengers and the harbour. The final element lands on the seabed. Harbour crossed. Now hear from the man who held it.
4 days holding 23,000 tonnes at 15 metres. That is the one that nearly broke us.
The trams above are shaking the road. The TBM below shakes the ground. Neither knows the other. 7 tunnel boring machines, 4 separate drives, and the ground changes between them. Every one is different. Pressurized slurry holds the face. The TBM drills in a bubble, 3 meters to the harbour. 400 old building piles are directly in the path. Break through or go around. No other way.
The lining ring goes in before the TBM moves. No ring, the ground above collapses. Simple.
The TBM is jammed 400 meters in. An uncharted concrete raft stops the cutter head completely. Probe port confirms the raft. Grout it from street level. TBM resumes in 8 days. Explosives in live Hong Kong granite. The blast calculated to spare the buildings 10 meters above. 200 sensors on buildings above. 1 reading over limit and blasting stops immediately. No exceptions ever. A 300-meter excavation with 50-year-old apartment blocks on all 4 sides. Diaphragm walls hold them. Workers hit a 900-year-old Song Dynasty site under the station box. 11 months lost. Already behind. $20 billion in delays. The station is redesigned around 900-year-old wells. The schedule shifts again.
The structural grid shifted 3 meters sideways. For a 900-year-old well, engineering lost that argument.
The ground under Exhibition Centre is still moving. Deep soil mixing stabilizes it before they dig. 3 buildings start sinking too fast. Emergency underpinning teams work through the night to hold them. 6 meters above the TBM crown, Harcourt Road. Cars above. The TBM is threading the needle. The geology is beaten, but the humans are about to fail, and it nearly ends everything. An inspector finds a disconnected rebar coupler buried in a live station wall. He finds 1,900 more. New platforms are going in below the existing station. Diaphragm walls 30 meters deep are the structure. This wall is poured once. It holds the excavation open, then it holds the station up, forever. Rebar couplers are the most critical connection in this wall, and someone is about to skip them. Short bars, not connected to couplers, dropped in wet concrete, poured over, buried inside the wall. The wall is carrying live train loads with 8.9% of its connection system missing. This is critical. Everything at Hung Hom Station stops. MTR halts all pours. Every wall is now under investigation. Now you might be thinking, how do you fix bars inside hardened concrete? It's brutal. A new steel frame takes the load away from the defective walls. The walls are bypassed.
Every train above runs its load through these steel beams, not through the defective wall.
650,000 tons of rock removed to install the fix, under a live station, without stopping the trains.
Last train, 45 minutes ago. By 5 a.m. this rock must be clear. Defective wall is right here.
5,000 tons of steel welded underground in the remedial space. No crane, no sky, just confined heat. The steel frame is carrying the load the defective wall cannot. The inquiry confirms, safe. Work resumes. 4 years stolen. And what comes next under Admiralty is more dangerous than anything done yet. 10,000 passengers per hour, and directly below their feet, workers drilling into rock. They don't know. The island line is 40 years old, trains every 3 minutes. Engineers dig directly below it. 22 millimeters settlement, 2 over limit. The island line tunnel is moving, last train running. Everything stops now.
Look at the ceiling!
You can hear the trains above them. You can see the dust falling. 22 millimeters of movement.
Heave it up!
No cranes, no room. Hand-tightening steel under a live railway. This is a danger zone. Steel props under the tunnel in 40 minutes. Engineers recalculate overnight. Settlement freezes at 23 millimeters. 650,000 tons of granite removed at night. The passengers use the station during the day, every day. The station grows downward. Each new slab forms below while passengers walk on the one above. 5,000 tons of steel assembled underground, through a shaft, in sections. No crane, no daylight, ever. The harbour tunnel moves 30 millimeters with every tide. The bored tunnel is fixed. The joint must flex. Standard Gina seal not rated for 30 millimeters movement at 3 bars for 100 years. New problem. Custom Omega seal outboard, tested at 2.5 times the pressure. 30 millimeter movement, 100 years. New standard. 25 meters deep into reclaimed land that is still settling. Diaphragm walls are the only thing holding. 4 lines, 4 levels, 40 meters deep. The lowest platform sits below a 40-year-old live tunnel.
40 meters below Admiralty Street, 3 levels above me, none touching the island line, by design.
6 meters below Harcourt Road. The TBM passes. The instruments above read 8 millimeters, within limits, barely.
Not at this scale. 3 live lines above the dig. This was the first time ever.
Everything in concrete and steel is done, but nothing inside has been switched on. Not yet. The concrete is set, the steel is in, but nothing inside has been switched on yet. The tunnel has been on the harbour floor for a year. Train tracks are going in now. The signalling system controls every train automatically. If it fails, no train moves. Not one. Ever. 8 months of reconfiguration, certified in 2022. But the signalling fix revealed something the engineers missed earlier. Here's what the signalling fix revealed. The platform screen doors and the trains aren't talking correctly yet. 27.5 kilovolts, 72-hour live test, 5,000 meters of tunnel energized, looking for any fault, any at all. 12 months of empty trains, every system stressed daily, every failure caught before a passenger boards. 23 groundwater sensors under the harbour. Any rise above baseline, a dive inspection in 24 hours.
A train just passed at 90 kilometers per hour above me. With the damper, I feel nothing. Without it, 4 millimeters.
Sensors 7 and 8 rising 0.4 millimeters daily. Limit is 0.5. The harbour is testing the seals already. The seal is intact. But sensor 7 is still rising 0.4 millimeters every day. Nobody knows why yet. 347 items closed. Inspectorate signs off. Tunnel certified. Engineers look at the weather models. 6 weeks. 2.3 million elements in the model. Storm surge loading from 0. The engineers watch the screens. Silent. A container ship crosses above the tunnel. Its propeller wash compresses the Gina seals below. Right now,